In the heart of the unforgiving desert, liquid gold is harvested on a massive scale. Camel milk is rare, potent, and notoriously difficult to produce in bulk. But here, ancient tradition meets cutting-edge industrial engineering.
Before milking begins, stress levels must be reduced to 0.
Diet is strictly controlled to ensure the unique mineral profile of the milk.
Every animal is digitally tracked, monitored for hydration and health daily.
Unlike cows, camels require a highly specific routine to release their milk.
This is one of the world's few specialized rotary parlors designed for camel anatomy.
Safety and comfort are prioritized to trigger the maternal letdown reflex. Hygiene is critical. One speck of desert dust could contaminate the batch.
Machines alone fail here. Human touch is still required to start the flow.
Once stimulated, the high-tech vacuum takes over.
Camel milk is lower in fat but richer in vitamins than cow milk.
Yields are low, only about 6 to 7 liters per camel per day. This scarcity is exactly why the price tag is so high. The extraction phase is complete, but the challenge of preservation has just begun.
The raw milk is immediately flash-cooled to 4 degrees Celsius.
From the warm desert sands, we now move into the sterile cold of the factory. Before it travels, the milk enters a state of suspended animation. Camel milk is extremely sensitive. It must be cooled within minutes to halt bacterial growth. It waits here only briefly. The transport fleet is already inbound.
Specialized insulated tankers are required to cross the scorching desert heat.
The transfer process is a closed loop. The milk never touches the open air. One loose seal could spoil thousands of liters in the desert sun. Pumps transfer the cargo at a rate of 1,000 liters per minute. Tamper-evident seals ensure the chain of custody remains unbroken.
If the temperature rises above 6 degrees, the entire load is rejected.
The processing facility is 50 miles away across the arid plains.
Every tanker is divided into compartments to maintain balance on the dunes. Now, the race against temperature begins.
Arrival at the main complex. But entry isn't guaranteed.
Every kilogram is accounted for to calculate yield and payments.
The intake bay is pressurized to keep dust and insects out.
Before a single drop is unloaded, the lab takes over.
This is the critical checkpoint.
If this sample fails the antibiotic or acidity test, the drain valve stays closed.
Results must be instant. The milk cannot sit in the truck for more than 15 minutes.
Only once the chemistry is verified does the physical unloading begin.
Gravity and pressure work together to store the raw milk in insulated giants.
The intake pumps engage, capable of emptying the tanker in under 12 minutes.
This isn't just a barn, it's a sterile pharmaceutical-grade processing center. Hundreds of specialized technicians operate this facility around the clock. Hygiene protocols here rival those of a silicon chip factory.
Street clothes are the enemy. No outside fibers are permitted past this point.
Every inch of skin and hair must be contained to prevent contamination.
Even the footwear is captive, washed and sterilized every night.
Manual washing isn't trusted. Automated systems guarantee a 20-second scrub.
The final barrier, an air shower to blast away any remaining microscopic dust particles.
Welcome to the white zone, the heart of the operation.
From here, raw milk is transformed into shelf-stable luxury.
This entire labyrinth of steel is controlled by 3 people and a million lines of code.
Every valve, pump, and sensor is monitored in real time. The command is sent. The processing begins.
Before processing, the milk enters a clarifier, spinning at 6,000 revolutions per minute.
First step, removing the invisible impurities. Impurities are ejected automatically, leaving only pure white liquid. Next, a specialized bactofuge removes 98% of bacteria spores physically, without heat.
Camel milk is unique. Its fat globules are bonded tightly to the protein, making separation difficult.
This mechanical purification preserves the delicate immune-boosting proteins that heat would destroy. Centrifugal force acts as a gravity multiplier, flinging out even the microscopic desert dust. To skim the fat, we use a rare, cold separation technique to avoid damaging the structure. The precious cream is siphoned off. It will be used for luxury cosmetics or butter.
The milk is standardized. Every carton must taste exactly the same, regardless of the season.
Now the pressure rises. We prepare to break the molecular structure.
It is physically perfect. Now, it must become biologically safe.
Pistons drive the milk through a gap narrower than a human hair. A balance tank ensures the flow remains constant before the critical heating phase. This recycles 90% of the thermal energy, cutting the factory's carbon footprint. The milk enters the regeneration bank, using outgoing hot milk to pre-warm the incoming cold milk. The impact shatters the fat globules, ensuring the milk remains smooth and creamy.
But camel milk proteins are fragile. Overheating them destroys the medicinal value.
The milk travels through this calibrated spiral for exactly 15 seconds.
The milk is prepped, standardized, and warmed. It's time for the main event. We are approaching the kill zone, the point of no return for bacteria. To make the milk safe, we must raise it to 72 degrees Celsius. If the temperature drops by even 0.1 degree,
the flow is instantly diverted back to the start.
The heat is stripped away instantly. Rapid cooling locks in the flavor.
Hourly samples ensure the pasteurization curve was perfect.
The test is negative for alkaline phosphatase. The milk is now safe and sterile.
15 seconds, long enough to kill pathogens, short enough to save the lactoferrin. To prevent oxidation, the liquid is blanketed under a layer of sterile nitrogen. The milk enters the aseptic buffer tank, waiting for the filling lines.
Fresh camel milk lasts days. But turned into powder, it can travel the world.
Here, the path divides. Fresh milk goes left. The rest goes to the drying tower.
Before drying, we must remove 80% of the water content.
Under a vacuum, the milk boils at low temperature, preserving the nutrients. It becomes condensed milk, thick, sweet, and concentrated.
The solid content has risen from 12% to 45%. It is ready for the tower. High-pressure pumps drive the concentrate to the very top of the facility.
We have reached the summit. Inside this tower, the final transformation occurs.
At the top of the tower, the atomizer wheel spins at 25,000 revolutions per minute.
Centrifugal force tears the liquid into droplets measuring just 50 microns.
A cyclonic blast of hot air hits the mist instantly. In a fraction of a second, the water vanishes. The milk is now a solid. It rains dry milk. 50 tons of liquid become 5 tons of powder. Gravity pulls the finished product into the secondary cooling bed.
A trace of lecithin is added here. Without it, the powder would never dissolve in water.
This process, called agglomeration, makes the milk instant and clump-free.
Pneumatic transport moves the powder at highway speeds to the packaging hall.
The powder is too hot to package. The fluidized bed shakes and cools it gently.
The rotary valve is the airlock. It delivers the powder without breaking the vacuum.
Perfect solubility. The batch is released for final packaging.
The bulk powder enters the high-speed canning line, untouched by human hands. Cyclones use physics to separate the valuable product from the transport air.
Empty cans are fed into the system at a rate of 200 per minute. Before canning, the batch must pass the solubility test.
The powder is temporarily stored in 1-ton sterile bags before canning.
The powder is ready. Now, the robots take over. Nothing is wasted. The finest dust is recycled back to the start to form new clusters.
A final sifter ensures no burnt particles or lumps make it to the customer.
Before filling, ionized air strips away static and microscopic debris.
Ultraviolet light sterilizes the interior, ensuring a hospital-grade environment.
The auger filler is accurate to within 1/10 of a gram. A measuring scoop is inserted, timed to the millisecond. Oxygen is the enemy. It is sucked out and replaced with inert nitrogen gas. This hermetic seal protects the milk for up to 3 years. If a can is light by a single gram, it is ruthlessly rejected.
X-ray scanners look through the metal, hunting for foreign objects.
A laser etches the batch code permanently. Ink can be erased. This cannot.
The product is secure. Now, it must be prepared for shipping. Steam shrinks the branding sleeve, creating a premium finish. Robotic packers handle heavy loads without fatigue or error.
The palletizer builds the stack with architectural precision.
Stability is key. The load is wrapped to survive international shipping.
Automated guided vehicles transport the cargo. No forklifts, no drivers. Bottles aren't bought, they are born here. It starts as a durable PET preform.
While powder travels globally, the fresh milk line races against the clock for local markets.
Infrared heat softens the plastic to exactly 100 degrees Celsius. 40 bars of pressure stretch the plastic into its final shape in under a second. Air conveyors transport the empty bottles to avoid crushing them. Before a drop of milk enters, the bottle must be clinically sterile. This is an aseptic zone. The air here is cleaner than in an operating theater.
Cold aseptic filling preserves the taste without the cooked flavor of UHT.
Gold caps signify the premium status of this desert white gold. Precision torque ensures a seal that is tight but easy to open. Induction waves fuse a foil seal to the rim without ever opening the cap. Brute force testing weeds out the weak seals.
Steam shrinks the label to fit the unique ergonomics of the bottle.
Air knives strip away moisture to prepare the surface for coating.
Labels are applied at a speed of 600 bottles per minute.
Every bottle is time-stamped to the minute of production. Spider robots pack the crates with a speed no human could match. From udder to bottle, the temperature has never exceeded 4 degrees.
1 bottle from every 1,000 is sacrificed for the sake of science.
The Quality Control Lab operates independently from the factory floor.
First, we hunt for the invisible. Microbial testing is non-negotiable.
Samples are incubated for 24 hours to ensure zero pathogen growth.
We analyze the chemical profile. The insulin-like proteins must be intact.
Chromatography separates the milk at a molecular level to verify vitamin content.
DNA sequencing is the only way to guarantee the product is authentic. Spectrometry detects heavy metals down to parts per billion.
Machines measure data, but only humans can judge the unique salty-sweet taste.
Texture and viscosity must be consistent, regardless of the season.
Packaging is tortured to ensure it survives the journey to supermarkets. We accelerate time. This bottle proves stability for 6 months in hot climates.
Digital traceability links every bottle back to the specific herd in the desert.
The science is settled. The batch is legally cleared for sale.
A library of liquid history is kept for legal protection.
The final stage begins. Flat cardboard is resurrected into shipping containers.
Adulteration is a crime. We confirm no cow or goat milk has been mixed in.
In the warehouse, the quarantine is lifted instantly.
Gravity packing ensures the bottles settle without scratching the labels.
Sealed and secured. Each box is now a self-contained unit. Heavy lifting is obsolete. Robots stack the cargo with geometric perfection.
And this is how modern factories produce camel milk from start to finish.
The convoy leaves. The cycle begins again at dawn. Refrigerated trucks maintain the critical temperature during the journey to the port. The milk has survived the desert, the factory, and the lab. The stretch hood technology waterproofs the entire load for ocean transport. Refrigerated trucks maintain the critical temperature during the journey to the port. We enter the automated cathedral of storage. No humans are allowed here. It is a triumph of logistics, biology, and engineering.
A facility designed to turn a scarce resource into a global commodity.
From the desert sands, this milk will land in London, Dubai, and New York within 48 hours. Refrigerated trucks maintain the critical temperature during the journey to the port.
The cold chain remains unbroken until the very last moment.
Here, the milk sleeps at -2 degrees until an order is placed.
These cranes operate in total darkness to save energy. Nature provided the animal. Science built the rest.